Okay, so now let's start the topic number systems. Okay, so in number systems, we are first gonna see about the decimal number system. So this decimal number system totally consists of 10 symbols from 0 to 9. That is 0, comma 1, comma 2, comma till 9. It's gonna consist of 10 symbols. Okay, and as decimal number system consists of 10 symbols, its base or radix is 10. That is, we can represent decimal number system such as like this. Like this is some variable and this can be represented by that 10. So that 10 is because decimal number system has 10 symbols. So next is that decimal number system is positional weighted. That means it depends on the weight from the decimal point. So for example, to understand that, we have this number, right? 9526.26. This can be represented as 9 into 10 power 3 plus 5 into 10 power 2 plus 2 into 10 power 10, and as follows. So this is basically the sum of product of each number or each symbol multiplied with its positional weight. So here the positional weight is 10 to the power 3. Here the positional weight is 10 to the power 2. So here the positional weight is 10 to the power 1 and 10 to the power 0. So this symbol is being multiplied with this symbol is being multiplied with its own positional weight, and then the total addition of those gives the value for the decimal number. So each of these small numbers, so if we see all this 9 comma 5 comma 2 comma 6 are all small numbers, but why 9 has a weight more than 9 has a weight of 1000 here, and 2 has a weight of tens here. So that is because each of the small number gets their value based on their personal weight. So based on where they are from the decimal point, it gets their own value. Okay, and so in a decimal number, the leftmost digit in the decimal number is called as MSD, which is called most significant digit. And the digit which is in the rightmost side, which is 6 here, is called LSD, which is the full form or abbreviation is least significant digit. The left is most significant and the right is least significant. Next, we'll see a method called 9's complement method. So this method is actually somewhat similar to 1's complement method. In this method, we subtract each digit of the decimal number from 9. So basically, if this is the decimal number, we subtract it with 9 to get the result. So this 9's complement method is mainly done to simplify the subtraction operation. So to understand the 9's complement way of subtraction, for example, if we want to subtract these two numbers, the number in the left is called as minuend and the number in the right is called as subtrahend. So to perform 9's complement way of subtraction, first we have to take the 9's complement of the subtrahend, 9's complement of the subtrahend, and add it with the minuend, 9's complement of this and add it with the minuend. So after adding, check if there is carry. If there is carry, add the carry to the LSD. LSD is the least significant digit, and the result is the answer. And if there is carry, it is known that it is a positive result. If carry is done after adding the minuend, then the answer is positive. But if there is no carry, then it indicates that the result is negative. If there is no carry, it indicates the result is negative. Then we add the minuend with the 9's complement of the subtrahend. So the same process, we take the 9's complement of the subtrahend and add with the minuend. And as there is no carry, it is a negative number. Now the result of this addition is again taken a 9's complement. So we again take the 9's complement of the result and we put a negative sign. Okay, so we'll see some examples. For positive, this is an example 745.81. We take 563.37 as a 9's complement of 436.62. So we add these two, and then as there's a carry 1, this is being going there. So this is known as end around carry, the process of taking the carry and adding it to the LSD, least significant LSD, least significant digit. This is known as end around carry, and the answer is positive. And if we go to the negative side, again we take 254.18 is 9's complement of 745.81. So we add these two, and then the result, and then we take 9's complement of the result. Because there is no carry, here, we take 9's complement of the result, and in the result we are adding a negative sign to represent that it is a negative result. Now why do we need 9's complement? So basically, doing an addition operation is very easy, as you only need the wheels to go forward. So for example, there is a mission. So this mission needs to perform both addition and subtraction. And for addition, the mission needs to go forward, and for subtraction, the mission needs to go backward. So it is really difficult for the machine to perform both the operations, as it needs two sets of completely different gears, levers, and springs to perform these two operations. So first of all, performing addition is very easy, but to subtract, we need to turn the wheel backward. But while doing the 9's complement, we can do subtraction by turning the wheels forward itself. So basically, we don't really need to turn the wheels backward, but while moving the wheels forward, we can technically subtract those two numbers. But we do subtract the 9 in the 9's complement, right? So doesn't that count as subtraction? But here we have the guarantee of no borrow. So the main problem in subtraction is borrow. Getting borrow from the MSD is a very tedious task. So in this way of subtraction, we know that 9 is the largest possible digit in its base. So for example, 9 is the largest possible between 0 to 9, and so 99 is the largest between 0 to 99, so as it goes on. So we know that there is no other digit larger than 9, so there is no possible way of borrow here. So that makes the subtraction pretty easier. Next, we go to the tens complement. In tens complement, we basically add 1 to the 9's complement. This is basically nothing but we do the 9's complement and then we add plus 1 to the least significant digit, LSD, of the 9's complement. So we can also subtract, we can also do the subtraction operation using the tens complement. So this is by first obtaining the tens complement of the subtrahend and adding it to the minuend. The same process, but here instead of 9's complement, we do the 10's complement and we're adding it to the minuend. If there is a carry, we ignore it, and the answer is the result. So here, if there is carry, the answer is positive, and then we ignore the carry. The carry is being ignored, and the answer is positive. If there is no carry, then this indicates that the answer is negative. And if the answer is negative, we take tens complement of the result and then put a negative sign with the answer. So if there is no carry, the answer is negative, we take tens complement. If there is carry, the answer is positive and the answer is a result. We do nothing. We do not take the tens complement again. So, what are all the flaws of nines complement and why do we need tens complement when there is nines complement? So, the main flaws are the zeros in nines complement are being represented as 0 as well as 9. So, 9 is basically 9 minus 0, which is also 9. So, 0 and 9 are both zeros, which is basically plus or minus 0. So mathematically they both are same, but for a computer it becomes twice as hard to recognize both 0 plus 0 and minus 0. But in tens complement there is only one representation for 0. So for example, if there is 9, okay, we basically add 1 to the LSD, right? So if that is 9, when we add 1, it becomes 10. So it becomes with 1 carry. So 9 plus 1 is 10, right? The answer is 0 and 1 is carry. So we basically have one representation for 0, which is basically 0. There's no plus or minus 0 at all. And in end around carry, it creates a second round of addition. So if we see here, this is the first round of addition, right? And after the first round of addition, when there is carry, we take the carry and add it with the least significant digit. Now this is the first round of addition and this is second round of addition. So here, when we are having a end around carry, we are having more than one rounds of addition, which actually makes the hardware a bit tough and it is also a bit time consuming. So instead of that, in tens complement, we do not have a second round of addition, but we add one during the tens complement itself. So the carry is already being added, and if there is another carry, it is being ignored. So it is as simple as that.